Hello everyone, my name is Anurag Sakya. Here I am designing 8-bit computer. So for a computer, I need a clock. So clock is here. The circuit for this clock is here. So it can it, there are two types of clock: manual clock and auto clock. When we are running any program, we can use auto clock. But suppose if there is any problem, we want to debug. So that time we can use manual clock. For auto clock, I have used 555 timer IC and some resistor and capacitor. From here I am taking the output. That output I am using for my computer as a clock. This one. This is 8 bus. So these are 8 LEDs connected to those bus. The what is the data in that bus we can see in the LED. If it is 1, it means there is 5 volt. So this LED will glow. Otherwise it will have 0. So I have designed this register chip. It consists of two registers, register A and B. So this is register A and this is register B. To design a register, I have used flip-flops and buffer. So the circuit for one register is here, this one. So here I have used 74LS173D. It can store 4 bit of data. This is 4-bit flip-flop. The same this one also. So total 8 bit of data this register can stop. So this is here for RS245. This one I am using to control the output. Whenever this enabled var signal will enabled, then the input to this buffer will go to the output. So register A, register B. So here, so two registers are here. This is my ALU. Suppose I want to perform any operation, addition or subtraction, then I can perform using this ALU. The content or the whatever is stored in the ALU, so we can see here in those LEDs. uh, this one is outward signal I have collected here, and this is subtract. Suppose I want to subtract two numbers, then I have to enable this signal subtract. So this the output of this ALU is directly connected to the bus, and and those registers A and B, they are also connected to the bus. So whatever is stored in those registers we can see here in these LEDs. This is for register A and this one is for register B, and this is my instruction register. So the circuit for ALU I had designed here using the same. This is just one adder, and using same adder we can subtract two number as well. I have taken first complement of that number, then I have added 1, then twice complement I am adding. So this adder can work as a subtractor also. So this is a signal to subtract. Suppose I want to subtract one number from the other, so I have to enable the subtract signal, and this is buffer to control the output. So for that I have to enable this control bar signal. So let's run this program. I will simulate this design. Here you can see this is the clock. It's blinking 1010. Suppose, or these are the signal. I will zoom it out. This is A in bar means what? Whenever I will enable this signal, then this the data of the bus will directly come to the register A. So this is A out bar signal, B in bar signal, and V out bar signal. So this is the bus. Suppose I want to enter these bits in the register A. So corresponding LEDs will go. So from here we can see the bus contains with the data through the bus is going, that is 10101000. So suppose I want to store this data in register A, so I will enable this A inverse signal. So I will enable. So you can see the same data is coming to this. A in var signal I have enabled. So the same data came to this register A. So I will stop writing in register A. Suppose I want to store something else in register B. So what I have to do? So first I will change the data. Suppose I want to store something this one. I want to store in register this one B this data. So I will enable this one. So you can see here the same data has been sent to register B also. So suppose I want to transfer the data from register A to register B. So I have to enable A out bar signal. That is A out bar signal here. This is A out bar signal. I will enable this one. So data from this register will go to the bus, and I will enable this B in var signal. So it will directly come to the register B. Okay, I will enable this one A out bar signal. So you can see the data same which was stored in register A. Register A contains this one, and oh sorry here this signal no outward signal is also enabled here. So whatever is the output of this ALU is going to the bus. So I have to first disable this one. Okay. Okay. Now you can see because the bus is only 8 bits, so only one signal we can enable to send the data to the bus. So here I will enable this outward signal, and I will enable this V in var signal. Look, the data from the A register first reached to the bus, and then the register B is connected to the bus, so it came to the register B as well. So you can see here also the same bit in the bus, the same bit has reached to the register B as well. You can see here. So suppose I want to stop. So you can see register A and register B are same. Now I want to use ALU. So first I will suppose I want to add two numbers. So I will this one I have to enable. Suppose I want to subtract. I want to add two numbers. I want to use my computer as a counter. Suppose so I will put one in. Suppose I want to start from the beginning. So first I will put one in register A. Okay, I will enable A in signal. Okay, one has come to the register A, and I want to put one in register B also. Okay, okay, one and one. Now what I want to do, I want to add two numbers. So you can see the sum of these two numbers, one and one is 10. So it is here. So I will enable this outward signal. So the sum of these two numbers will go to here to the bus, and I will enable A in var signal. So directly it will come to the A register A, and again it will be added. Again the sum will come to this ALU, and again it will be feed to the bus. So it will keep on going. Let's enable this outward signal, and I will enable this var signal. You can see here the sum is now the register A has been updated. It is 3 and it is 1 adding. So this sum is now 6. Here